Hey friends, so now I'm going to talk about the most important concepts that you will learn in programming. It is what separates casual coding from professional coding. I'm talking here about the functions. This is of course not a Python thing. You're going to find functions in every programming language. And to be honest, learning functions can get you overwhelmed and confused at the start. That is totally normal, so don't rush it, but I need you here full focused because this is a skill that we need to get right. And my friends, don't worry, I'm gonna take you step by step from the very basics about the functions, and then I'm gonna walk you through to the advanced topics where you're gonna learn how we write functions in real projects. So now let's start with the basics, and we're gonna start with the first question. What is a function? A function is a small reusable block of code that does one specific job. It's like a machine that can take an input and it can return something back. So actually that's it. It's very simple, but we have to understand now exactly what this means and why do we have even functions. So now the thing is, as you are coding, you usually write a small logic or flow in order to solve a small problem. Now over the time you might face a very similar problem where the logic gonna be almost the same as the previous one. So what you're gonna do, you're gonna go and copy the code and paste it. At the start this sounds really okay, but over the time you're gonna find out that the same logic exists multiple times in your code. And this is the start of the chaos, because imagine you found a bug or something wrong inside this logic, or maybe over the time the requirement changed. So now things get really annoying because you have to remember all the places where you use this logic and then do the changes. And believe me, in a real project, your code gonna be really massive. And of course, I promise you, at least you're gonna miss one. So now some of the logic got updated, the others using the old logic, which gonna make the result of your code inaccurate. So that means if you leave it like this, it's gonna be really hard to change. And as well, it's gonna be really hard for you to read. It's gonna be a really big script. And you're gonna get the feeling that it's gonna be really risky to touch anything in your code. So the bigger your project gets, the worse this becomes. And of course, what is the solution for this? We're gonna use functions. So instead of repeating the same logic over and over, you're gonna take your logic and put it in one place inside a function. And whenever you need this logic, this behavior, you just call the function. So you don't rewrite it, you don't copy and paste, you are just reusing the same logic whenever you want. And by doing this, actually all the problems gonna disappear. So since everything in one place, if you found, for example, a bug or something wrong in the logic, or maybe the requirement changed, all what you have to do is to just go to the function and do the change only once. And with that, every part of your program that is using it automatically gonna get the new behavior or the new updates. That means, my friends, the change is gonna be very fast because you are just changing one code. You are not changing like multiple things. And very important as well, it is now more safe to change the code. You are no longer touching many parts of your code. You are just changing one clear isolated piece. Now, another big win is that your code gonna be smaller because you don't have any more repetitions, which gonna make your code, first of all, readable, and as well, it's gonna be easy for everyone to understand your code. And by using functions as well, it improves the collaborations in projects. For example, we can split the work. One person can work on the function and another one can work on the rest of the code. And another thing, since we are talking about teams, it as well speed up the projects. And this is what usually happen. Different developers gonna work on similar problems. So now instead of each one of them writing the code from the scratch, we can start reusing stuff. So we can say, for example, hey, I already done this issue. I have a function for it, so just go and reuse it. With that, we save a lot of time, we avoid reinventing the wheel, and the whole project can be faster. And now we come to the last benefit of using functions gonna introduce something called modularity. So this is a way of breaking big complex problem into smaller manageable pieces. So that means functions, it is one tool in order to overcome complex problems where you divide and conquer. You divide the problems into smaller pieces and you put them in different functions. So that means as you learn functions, you are actually learning how to think like a developer. Those are my top reasons why functions are one of the most important topics in Python. Alright my friends, so now we come to a topic where I totally understand if you tell me, you know what, Para, we already learned about functions. So we have the string, the number, the data structure functions. Are we gonna learn more functions now? Well, the thing is, all those functions are built-in functions, so something that already exists and we are just using it. Now we are talking about functions that you're gonna create from the scratch. So that means, my friends, there are like different sources where functions come from. Let me show you what I mean. So the first source of functions and the simplest one is the built-in functions, and that comes directly with Python. They are always there. You don't need to install or import anything. You just go and use them. We already worked with many of them, like the print, the length, type, changing the data types, int, string. We already use them a lot without thinking about it. The second source is the one that comes from libraries, and here we have like two types of libraries. The first one is the Python standards library. This one is written by Python team. So the thing is, those functions are very specific and advanced that they don't expect you to use it all time in your code. So that means first we have to import the library, and only after that we can start using its function. Now, for example, we have the module math if you want to do advanced calculations on numbers, and another one we have the date time and random. So this is one source. Another source called external libraries. These libraries are written by the community, by other developers, or maybe as well by companies, and they were nice enough to share it with us. Now, in order to use them, we have to do an extra step. So first we have to install the external libraries because they don't come with Python, and then after that we have to import them, and finally you can start using its function. Now there are a lot of famous libraries like the pandas to do data analysis and to clean up the data. Another one is the matplotlib in order to do data visualizations. We have the numpy to work with numbers and arrays. And my friends, this one is the biggest strength of Python. There are outside thousands of people that are working on solutions and sharing it in libraries. And to be honest, this is what we do in projects. All what we have to do is to just plug and play, install, import, and reuse work that already exists. So now for those two sources, the built-in and the libraries, you don't have to deal with the definition of the function. So you don't have to know exactly what is inside the function. You just use them. Other people gonna deal with the definitions and work on it. But now still, my friend, there are some scenarios in your project, things gonna get very specific and you have to write your own definition, your own functions. We call them user-defined functions. So this time we will not install or import anything. We have to define the function and then of course use it. So we are doing things from the scratch. So those are the three different sources of functions. And now of course the question is, if I have a problem and I want to solve it, which source should I use? There is a simple golden rule for that. If you follow it, you are already thinking like a professional. Before you write any piece of code like a function from the scratch, always check if it already exists somewhere else. So just don't reinvent the wheel. So here how to do it. First, check the built-in functions because they are already there and they are usually very safe and fast to use. If you are not finding anything, then go and check the standard libraries because they are already installed and trusted. So all that you have to do is install, import, and use. Now, if you don't find the solution in the libraries, then it must be written from scratch. But now even here, before you start writing it on your own, go and ask your team. So check your project and ask your colleagues because this is the nature of projects. The same problems, or let's say the same logic, shows up again and again, and maybe one of your colleagues already solved it and built a function for it. So all you have to do is to just reuse the already existing function. But now it could happen that you didn't find anything, so your problem is very specific. Only in this case, you're gonna go and write it on your own from the scratch. So the idea is very simple. Always check whether it already exists and reuse it before you write anything or any function from the scratch. So this is how we decide on which source we should use. And now of course we're gonna focus on the user-defined functions. So let's dive in. Now, the user-defined function has two parts, the function definition and the function call. The function definition, or sometimes we call it declaration, it is where you describe the function, so what the function should do. And the syntax for that starts with the keyword def, so with that Python will understand, this is a definition of a function. And after that, you specify the function name, so it is just any name that you give it, then parentheses and a colon. Now, below that, we're gonna have the block of code. Of course, we're gonna use the indentation in order for Python to understand. This is the body of the function. And here, depend on the logic, we can add some normal Python code, like assigning values to variables, or making a loop, a conditional statement, or maybe call another built-in function. So with that, Python understands the definition of your function, it understands what it should do, but nothing runs yet. That's why we have the second part. The function call is how you use the function. And it is very simple. You just write the function name, followed by parentheses. So once Python Python sees it, it's gonna go and execute the function like any other built-in function that we used before. So very simple. The definition, you describe your function, and the call, it is where you execute your code. Now let's have a very simple example in order to understand how Python gonna execute it behind the scenes. So we're gonna add a print at the start and print at the end, and our function gonna be very simple. It is a greet function where it has only one thing to do, to print hello. So that's it. Now if you execute this as usual, Python gonna start from the top. So the first line, they're gonna go and print the start in the output, nothing fancy. Then it's gonna go to the next line, and now Python gonna see a diff, so it has to define a function. Now how it's gonna do it, Python will not go to the next line inside the function to the print hello and execute it. Instead, Python gonna go and create an object in the memory, and then it's gonna put inside it the function name, the body of the function, and some extra stuff. So the definition step means it is only saving the function inside the memory without executing whatever inside the function. So nothing happens so far on the screen, and now Python gonna go to the next step, which is not inside. It's gonna go to the call of the function. So Python gonna see the function call greet. So it's gonna go and check the memory, and it's gonna find it. So now what's gonna happen, it's gonna go inside the body of the function and start executing it line by line from the top to the bottom. Well, here we have only one line, so it's gonna be very simple. Python gonna print in the output hello. After that, Python gonna exit your function and goes back to your code where it was. So it's gonna go to the next line, print end. It is a normal line of code. So at the output, we're gonna see start, hello, and end. So I just want you to understand this one thing. If you define a function, that means Python is creating an object in the memory, and that means it is not yet executing the function, and the function call gonna be the one that's gonna execute it. So this is how Python works internally with the user-defined functions. Okay, so now let's practice a little bit. First, I'm going to show you why we need functions. So let's have a very simple example where we are describing our morning routine. So the first thing that I do usually is to wake up. I am a morning guy, so I wake up at 5. After that, the first thing I do is I need my coffee. So I'm going to start the coffee machine. So now I'm describing the process. After that, I'm going to make the coffee. And the last step is I'm going to drink it. So I'm going to enjoy it. Now, after I have my first coffee, I will be working for a while. So I will do stuff. Previously, I worked on my full-time job, but now I'm just making content. Now, after a while, usually I need my second cup of coffee. So I need to do the whole process again. So I'm going to start the machine, make the coffee, enjoy it. So what I'm going to do, I'm going to copy the whole thing and just put it over here and then keep working, having lunch and etc. Now, let's go and print this first in the output. Now I can see all my steps. Now, as you can see, we have a process. We have a logic that exists actually twice. And this is not a nice thing because I might do changes to this process. Like, for example, maybe I start drinking some different type of coffee where I add the milk to it. Now, if I want to go and add this step, I have to do it over here. Add milk, and then I have to make sure that the same step is as well added in the next workflow. So after making the coffee, I will go and add the milk. Now let's go and execute it. Now we have those steps, but as you can see, it was a little bit annoying where I have to make sure to make the same change twice. But this is not really nice. Instead, we're gonna put the whole logic of making the coffee in one function, in one place, and call it whenever we want. So how are we gonna do it? Usually we're gonna go to the top of our code at the start, and we use the keyword def. So with that, we are defining our function, and now we have to come up with a function name, like for example, make coffee. And after that, we have to put the parentheses and the colon. So now we are ready. After that, hit enter. Python gonna gives you the indentation, the 4 spaces. And now what we want is to put our logic, the process inside it. It starts from here until enjoying the coffee. So I'm gonna cut it from here and then put it in the body of the function. But this will not work. We have to go and give it a tab. With that, we have the indentation, and Python can understand, those 4 lines belongs to the function make coffee. Okay, so now let's go and just execute it. Now look to the daily routine. It is not correct anymore. So wake up, working for a while. Where is my coffee in between? And that's because Python will not execute those steps. We are just defining the function. So Python is just creating the objects without executing it. Now in order to execute it, it's going to be very easy. We will just use our nice function name. So as you can see, even the editor now is suggesting the function name. So make a coffee, and then the double parentheses, and that's it. So now let's go and execute it. Look at this, we have again our daily routine. And now I just noticed that I have a typo with the machine. And this is perfect because I can show you now the benefit of having function. Now everything in one place, I just have to do the change and the fix only once. So I'm gonna go over here and say machine, and that's it. I don't have to go to the second place, because I will remove those steps and just use the function call again. So make coffee and double parentheses. So as you can see, it was very easy to fix in one place. Now, if I go and execute it, with that, we have everything correct. So as you can see, the output gonna stay the same. There is no extra stuff that's gonna happen. It is just we developers, how we work with the logic, with our code. So we are organizing and making things more usable, and we are reducing the risk of making mistakes. And now if I decide to make a third cup of coffee, it's gonna be just calling the function. I don't have to copy and paste anything. So just the function name and execute. And with that, I'm gonna get my third cup of coffee. So this is the magic of using functions in Python. So my code is simple. It is easy to read, easy to write, easy to understand, and everything is now more professional. All right, so now I'm gonna show you quickly the different sorts of functions that we have in Python. The first one, as we said, it is the built-in function. So for example, if I'm calculating the length of a word like Python, so actually that's it. This is a built-in function and we are just calling. So now let's go and try a function from library. For example, let's have a number like 4.2. This is a decimal number, but I would like to have a whole number. And in order to do that, we have different ways. One of them is using ceiling. So now we don't have out of the box like a built-in function in order to do the ceiling, but we have a nice function inside the Python standard library from the module math. Now, of course, I cannot go and just use it. So it is like this ceil, and then we pass for it a decimal number. As you can see, Python gonna have it like as a white. And if you execute it, you're gonna get an error. So Python does not understand what is ceil. And that's because it is not built in. We have to import it first. So what we're gonna do, we usually do it at the start. So we're gonna go and import the module math. And in order to tell Python that this function comes from this module, we have to put before it the math dots. And now it is green. And now Python can understand, this comes from the standard library. So if you go and execute it, you will not get an error. And we are getting now a whole number using a ceiling. That means we are first importing and then we call. So now, as you can see, for those functions that we are using, we don't know the definition. So we don't know the block of code that is used in order to do the job. So we don't have to know the code behind those functions. But for the third type, the user defined function, of course, we have to define it and we have to tell Python exactly what are the steps. So for example, we are just greet and then colon, and then the definition is simple. So hello, and then a new line, but make sure you are outside. We just go and call the function. So let's go and execute it. With that, we have hello. So what are the steps? You define first and then call. So now, my friends, it really depends on the editor and the theme that you are using. But for me, once I see a green, that means it is a function. And those are quickly the 3 Python sources for functions. So far, we have covered all the basics about the Python function. Now we have to take things to the next level, where we have to understand something really important: how our data actually move through a function. So we're gonna learn things like the parameters, argument, how to return an output of a function, and we have to understand as well the different types, shapes, and purposes of functions. So let's dive in. Now, before we start talking about the syntax, we have to understand one core idea. Not all functions work the same way. So some functions, like we learned before, they don't take any data. So the data doesn't go inside, or there is no data goes outside. It is just a block of code that's gonna run and do something and then stop. That's it. But there is another shape of function that actually takes data in. So it has an input, it's gonna perform an action and then stops. That means it has no output, there will be no data going outside. And some other shape where you have a function that it accepts an input, so it takes data in, then it transforms it, and then it returns the result as an output. The data gonna get out of the function. So data goes in and data goes out. but with different shape after it gets transformed. Of course, some functions takes multiple inputs, so multiple data goes inside, then something gonna happen, then they're gonna do calculations and transformations, and then you could have as well multiple outputs. Multiple data are going outside. So as you can see, you can design the function the way that you need. You have different shapes. You could let data go in and as well go out. Now in Python, we have different terminology about the input and the output. We call the data that goes in through an input, we call it parameters and arguments. And the data that comes out, we call it return value. So from now on, I will not say like an output and an input. We're going to use those terminology. So this is the big picture. Different shapes means different data flow. And now we're going to deep dive into the input, the parameters and the arguments. So let's go. So now, what are parameters and arguments? The parameters are names that you write in the function definition in order to describe what kind of data the function expects. So you are describing the input. The arguments are the real values that you pass when you call the function. So they are your actual data that is used when the function is executed. And of course, this might sound a little bit confusing, but in order to understand it, I'm going to show you an example and how things works behind the scenes. Okay, so now first let's talk about the syntax. As we learned before, if you want to build a function, you need two blocks. You need the function definition and as well the function call. So now what we're going to do, we're going to extend it in order to accept data in. So now between the parentheses, we're going to go and put the parameter name. That means in the function definition, we define the parameters. So this is where it goes. Now about the function call, we put there something else. We call it argument. We're going to put an argument value in the function call. So now let's say that I would like to build a function that's going to go and multiply any value by 2. So how are we going to do it? We're going to call the function times 2. This is the function name. And now we have to specify a name for the parameter. So it could be any name, like for example, I'm going to go with the x. And now we're going to write the function. We're going to go and print the result of multiplying the parameter with 2. So x multiplied by 2. And actually that's it for the definition. Now in the function call, we're going to use again the function name. And now we have to specify an argument value. So as you hear me, I'm saying a value, so not a name. So it could be any value, like for example, let's say 3. As you can see, it is very simple. The syntax stays the same, but we just added a parameter in the definition and our value, the argument, in the call. So now once you execute it, it's going to go line by line. It's going to start with the def. Python can understand, okay, this is the definition of the function. So it will not go inside it and do anything. Instead, it's going to go and create an object in the memory where it's going to put the function name, the definition of the function, and a list of parameters. So now since here we have only one parameter, it's going to be the x. So it has no value and the parameter here is like a placeholder, nothing inside it yet. So that's it. Once it's created, Python going to go to the next line, which is the function call. Now Python going to see, okay, I know this name, I have it in the memory, and now it's time to execute the function. But first there is one step to be done, which is Python going to go and take the argument value and it's going to go and assign it for the parameter. So if you are looking at this looks exactly like variables, where you have a variable name and a variable value. So the name is here the parameter, the argument here is the value. So with that, we just filled the placeholder with a value. Now after the assignment, Python gonna go and start executing the function. It's gonna see the function print, and inside it, it must do the calculation first. So it's gonna pick the value that is assigned to the local variable x. Here we have it at 3, and then it's gonna go and multiply it by 2. So we're gonna have the value 6, and it's gonna go and print it in the output. So now once it's done, it is very important to understand, it's gonna go and destroy the whole local variable with its value. So everything gonna be lost, and again we're gonna have an empty parameter as a placeholder. So all I want you to understand from here is that when the function is defined, the parameter is gonna be like a placeholder. It's gonna be empty, no value inside it, and only when the function is called and executed, Python gonna take the argument value, assign it to the parameter, so it is filling the placeholder, and then use the whole thing as a local variable. And once the function finishes, everything disappears. So this is what happens behind the scenes once you start using parameters and arguments. So just quick comparison between the parameters and the arguments. The parameters are used in the function definition. The arguments are used in the function call. The parameters are the placeholder, and the arguments are the real value that's gonna fill the placeholder. So a parameter is only a definition on what a function expects. So it defines the input, and the arguments provides your actual data that's gonna go inside the function. So it is very simple. Alright, so now let's practice in Python. Let's say that I have the following name and the quality of the name is not really good. So we have at the start some space and then we have Maria like this. So the cases are messed up and at the end we have like 2 spaces. So that means the quality of the name is not really good. I would like now to go and process the name in order to make it more clean. Of course, in order to do that, we're gonna use the string methods. So the strip gonna go and clean up all those white spaces. Of course, in order to see the results, let's go and print it. Now, if you check the output, you can see we don't have any more spaces. And the second step, we want to deal with the cases. So I'm gonna go with the lower case. So lower, and then execute. Now look at this, the name is processed and clean. With that, we are doing some data transformations and cleanup. But now let's say that in our project, always the text comes like this. We have spaces, we have weird cases, and this rule, I'm gonna apply it over and over. So now instead of repeating the same steps over and over to say, okay, strip and then lower, what I can do, I can put this rule, this logic inside the function. I have it once and I can use it whenever I want. So now let's go and do it. I usually put the definition at the start, so I'm gonna say diff. We have to define the function and then the function name. You can call it clean name, but if you want to make it more generic, maybe you want to clean as well the addresses or the countries and stuff like that, you can say, okay, clean text or string or whatever, but I'm gonna leave it for now for clean name. And now, of course, we have to put the parentheses and then at the end, the double points. So now I'm going to take the whole thing and put it inside the function. And of course, we have to add the indentations, so the spaces. And with that, we have the definition of the function. So now what is missing is, of course, we have to call the function. So we're going to say clean name. And actually, that's it. So now if you go and execute it, you're going to get the exact same result. So you're going to get Maria, where the name is cleaned. But of course, we have an issue. So now if I go and just execute the function multiple times, I'm always transforming the same value. So we have Maria 3 times. But in my project, I have different values and different names, not only one. So it will not work that each time I'm going to go and change the name inside the function. Instead, I want it to be more flexible, where each time I'm going to give it my own value. So that means, my friend, we have to change the shape of this function so that data goes in. So how are we going to do it? It is very simple. First, we have to change the definition. So now inside the parentheses, we're going to give the parameter name, and it's going to be just the name. Now look at this, something changed already. And now the next step is that we're going to go and remove this assignment, because the values will not come from the function itself, it will come from outside. So that means I'm going to take the value Maria from here and put it as an argument for the function call. So something like this, and then just remove this over here. And with that, we have only one line inside the definition. So you can see inside the function, there are no values at all. It's just describing what's going to happen to the parameter. So now let me just try this out. I'm gonna remove those stuff and then let's go and execute. Look at this, the result is the same, but this time the value is coming from the outside as an argument, not a static value inside the function. Now let me show you how cool is this. Now we can call the function, but using different arguments. So for example, let's say we're gonna have Kumar, everything with capital letter, and at the end we have one space. Now let's clean up this name and execute. Look at this again, we have the same standards. So the white spaces are removed and everything in lowercase. So as you can see now, my function is more professional. It is more generic, that I can accept any value. So it is very cool and you can keep giving it values as much as you need. But now one more thing, of course, if you execute it without any argument, you're going to get an error, because the function has a parameter and it expects an argument. So you cannot leave it like this. But of course, if you don't want to pass any value, you can pass for it like an empty. This can still work, but you have to pass something. So this is how we use a parameter and an argument in order to build an input to our function, which can make things more flexible and professional. Alright friends, so now once you start working with parameters and functions, you're gonna get the feeling that they look like variables. So why do we have like parameters? And what are the differences between them? Well, I totally understand this topic is very confusing for beginners, because in Python we usually have like 3 kinds of variables. We have parameters, local variables, and global variables. Well, at the end it comes actually to only 2 things: how long they live and who can access them. So now, of course, as usual, I'm going to show you in details using animated sketches the differences between them. So let's dive in. Okay, now by looking back to our very simple function where we are multiplying things by 2, so it accepts an input, then multiply it by 2 and print it out. So now the x here, the input, it is our parameter, so nothing new so far. Now let's extend it by adding a new variable completely outside the function. So for example, the f, it is equal to 2. Now since this is outside of our function, we call it a global variable. A global variable, it is a variable that is created outside the function and available everywhere to be accessed throughout the program. So that means actually inside the function I can access this variable and I can say, okay, multiply the parameter by the variable f instead of 2, so that I am flexible on how to multiply, and I can call the function multiply by factor. So this is a second type of variable. Now coming to the third one, we're gonna go inside the function and create inside it a new variable. So we're gonna say the variable y gonna hold the final result of our calculation, and then at the end we're gonna print the y. So now since this variable is inside the function, we call it a local variable. So a local variable, it is created inside the function, and here the big difference, it is only available for this function, not globally for everything else. So those are the three different types of variables, but of course in order to understand it, let's see what's gonna happen behind the scenes once you execute it. So now as usual, Python gonna go step by step from the top to the bottom. So now the first line, it's gonna go and create in the memory a variable called f, and gonna assign for it a value 2. So at this point the variable exists and available to be used. Now it's gonna go to the second line where it's gonna see a def. So Python gonna understand, okay, I'm gonna go and create in the memory an object called function. It has a name, so multiply by factor, and inside it it's gonna go and put the body, the function code, and then a list of parameters. Since we have only one, then we're gonna have only the x, but without any value yet. So we have only the name of the parameter, and now comes something very important. The local variable y is not created yet, and that's because, as we learned in the definition of the function, Python will not go inside the body and start executing its code. And of course, without executing, Python will not know about the local variable. All what Python knows is we have a global variable, the f, and its value 2. We have a parameter called x, but we don't know yet its value, and it knows nothing about the local variables. So now once it's created, Python gonna go to the next line, and here we have the function call with an argument value 3. So now what's gonna happen first, Python gonna take the argument value, the 3, and assign it to the parameter. Now Python knows its value, x is equal to 3, and then it's gonna go to the next step and start executing the body. So now the next step is gonna see the y and the calculation. So first it's gonna execute the right side, so it's gonna go and get the value of the x. This example is gonna be the 3, and then it needs the value of the f. So it's gonna go and access the global variable and get the 2. So with that we have the 3 and the 2, it's gonna go and multiply it, and now Python have y is equal to 6, and only at this moment Python gonna go and create a new variable called y, but this variable is a local one, and it's gonna assign for it the value 6. So with that is done, it's gonna go to the next step where it's gonna go and print the y. So it's gonna access the local variable, take its value and print it in the output. So that Python is done executing the body of the function, and now comes something very critical to understand. Python gonna go and remove the argument from the parameter. So our parameter gonna go again as an empty placeholder, but of course it will not destroy the parameter itself. It is just unassigning the value. And the second step is gonna go and destroy the local variable y, not only its value, the whole thing, the variable name and as well its value. So by the end, this variable is totally unavailable and we has no idea about it. So at this point we are back to the first point. Python knows there is a global variable, it knows there is a parameter called x, and it has no idea about the local variable y because it destroyed it. So now by looking to this, you can understand exactly the lifetime of each of those variables. The global variable, the f, has the longest life. It's gonna be created at the start of the program and it's gonna live as long as the program runs. Once the program ends, Python gonna go and destroy the global variable. The local variable has the shortest life, so it's gonna be created when the function runs and it's gonna be destroyed after the function ends. So it is totally temporary. Same things for the parameter, its value gonna live as long as the function is running. The second point that it is very critical to understand is how those stuff are accessed. Now about the global parameter, you can access it anywhere. In our example, inside the function we accessed the global variable, and as well outside outside the function. Like for example, if you say printf, you will not get any errors and you can access its value. But now for the parameters and the local variables, it is totally different. You can use them only inside the function and not outside. Like for example, here inside, it was totally okay. So we used the parameter x in the calculation, we printed the y, everything is happening inside the function. But now once you go outside, whether before or after you say print y, Python will not understand what you are talking about because in the memory there is no object called y. Same thing goes for the parameter. You're gonna get an error if you do that outside the function because Python sees only the object f and the function object. Of course, you cannot use its parameter without calling it first. So let's recap. The global variable, they have long life, so they will be created at the start and destroyed by the end of the whole program, and they can be accessed everywhere, whether inside the function, outside, wherever you want. But the local variables and the parameters, they have short life. They only live during the execution of the function, and they can only accessed inside the function, not outside. And those are exactly the differences between them. Alright, now back to our example in order to practice. And if you look to this, we have one thing. We have only the parameter. So now let's go and add more stuff, like for example, a local variable. So we're going to go inside the function and create something called cleaned. And now we're going to go and put the whole thing, the whole modifications of the parameter, and the output of the methods going to be stored inside our local variable. So now actually this is as well best practices on how to do this function, because here things are more clear for you. Like for example, usually the parameter holds the raw data. So this is the input. Then we are going to modify the raw data and then store the process data inside a new variable so that you can understand immediately, okay, the raw data inside the name and the process data inside a new local variable called cleaned. This is very logical and easier for you to understand the purpose of the function. And with that, actually, you have now the two versions of the data, the raw data and the process data. So this is clearly a big win for you if you introduce the local variable. And now what we're going to do, we want, of course, to print the local variable, the new processed value, cleaned. So again, the parameter is defined here, and here we have a local variable. So now before I execute, I will just remove this over here and then let's go and run it. As you can see, we are going to get the same results. So this is going to work as long as you are inside the function. So actually you can go and as well print the parameter name. We're going to say row double points and then the name. And here we're going to say cleaned double point, and then we can execute. So by introducing the local variable, now I am able to access the old value and as well the clean value. So now of course this is going to work as long as you are inside the function. So for example, if I take the parameter and just print it outside and then execute, but I'm going to say, what are you talking about? There is nothing called name. Same thing goes for the cleaned. So if I go over here and execute it, it's going to say, I don't know what you are talking about. So whether you put it before or after, it will not work. So parameter local variables only inside the function. And now let's go and introduce a global variable. Now I'm going to make it a little bit interesting, where you're going to say, you know what, I'm going to control whether we lower the case or not using a global variable. So in our project, we're going to say, you know what, the case rule going to be lower. So it is just like a global variable. So this is global variable, and only if it is lower, then the function must lower the case. So with that, I'm creating like a logic. I need to build like a condition, and for that, of course, we can go and use the if statement. So now we're going to go and access the global variable case rule. If this is equal to lower, only then go and apply the method lower. So I will not go and apply it right away. What we're gonna do, we're gonna say cleaned, gonna be cleaned dot lower. Otherwise, if the function is not lower, then don't go and apply it. So it is very simple. Now I will just go and remove this print over here. And of course, we can go and try this out. Now look at this. We have Maria and everything is lowered. So now let's say that the rule is now do nothing. So NA, you don't have to lower any case. So now if you go and execute it, you can see the cases is like the original. So that means the method lower is not applied because the rule says something else. So my friends, as you can see, we are able to access the global variable inside the function, and as well, we can access it outside. So we can say the rule is double points and then the case rule. So this is very classical one. You can see it can work. So inside and outside, but the parameter and the local variables, this is something very specific and we can access it only inside the function. So my friends, as you can see, again, it's very simple. Those are the three different types of variables. Alright friends, so far we just talked about only one input, one parameter, and this is something rarely happen in real code. Instead, we usually send a lot of data to functions. So that means we need multiple parameters and multiple arguments. And here it's going to be tricky about the order of the arguments. So now let's see how we're going to do that. Okay, so now back to our example where we have only one input, one parameter. And now I'm going to go and extend it where we're going to say, you know what, I'm going to send both the first name and the last name to be cleaned. And maybe at the end, it should be merged in a full name. So there will be multiple steps. That means we need two informations goes inside the function. We have to change the definition, not only the first name, but also the last name. I'm just going to make the underscore. So now my function accepts two parameters, two values. And of course, we have to do something with those two values. So the first one, I'm going to call it just first and then first name. And I'm going to do the same steps for the last name. So last name dot strip. And we're going to lower the cases as well. And then the last step, we're going to say full name equal first plus, and maybe we're going to add some space to look nicer, and then last. And at the end, we're going to go and print the full name, right? So actually that's it. This is the definition. We accept two values, first name and last name. We're going to go and clean them up, then combine them together and print it in the output. So that's all about the definition. Now, if you leave everything like this and execute, you're going to get an error because Python going to say, you know what, you have here two parameters, you have to pass for me as well two values. So is Maria now for the first name, the last name? It will not work. That's why as well you have to pass multiple arguments. So in the function call, you have to say, okay, Maria, and then comma. It's like the parameters. So you just make a list of values and maybe Smith, and then space. So now let's go and try this out. Look at this. Now we have the full name, Maria Smith, everything lowercase. There is no spaces or whatever, and they are combined together. So you can keep extending your function and sending more data. Like for example, I'm going to say here the country, and maybe the country, I will not edit it at all. I will just print it at the output. I'm going to say from and then country. And now in order to pass for this the value, of course, I have to extend it and maybe say DE. So now if I go and execute it, it's going to say Maria Smith from DE, Germany. So as you can see, it is very simple to extend. All right, so now the next step, I'm going to start talking about the arguments because in Python, we have two different ways on how to send the values to the function. Those ways has some fancy names, like we have the positional arguments and the keyword arguments. So the positional arguments are values passed to the function based on their order, and the keyword arguments are values that are passed to the function by the name of the parameter. They might sound very similar, but actually they have a different behavior. So now let's check the positional arguments. Actually, we already using it. So if you think about the syntax, this is a positional argument. It's all about how Python is mapping those values to the parameters. So we are saying the first value is actually for the first parameter, the second argument for the second parameter, the third for the third. This is what we mean with the positional arguments. So that means the order of the values over here is really important. And this is of course very scary because if you go and make something wrong, we all do mistakes. So if you put the country first, then first name, last name, and then you go and execute it, you will not get an error, but your data will make no sense. D. Maria from Smith. Well, maybe the first part makes sense, but the whole thing is messed up because Python does not care whether the data is correct or not. It's just gonna go blindly and trust your order. So the first for the first, the second for second, and so on. That's why it is risky. But there's another way on how to do this by using the name of the parameters in the call. So let me show you what I mean. Now we're gonna use the name of the parameter, first name, then equal, and then the first name. It's like you are creating variables and assigning to it values. So you're going to keep repeating the same things. Last name equal, then Smith, and just make it smaller, and then country equal to DE. Now, if you go and execute it, you will get the exact same results. Maria Smith from DE. So actually that's it. This is the syntax of the keyword arguments. Now, of course, the interesting part, if you go and do mistakes and you put the country at the start, and then you go and execute, then everything gonna be fine. Because now Python knows which value belongs to which parameter, even if the order makes no sense. It knows, okay, DE for the parameter country, and it's gonna go and assign it really to the country. So if you messed up with the order, then it's gonna be fine. And this is a very big advantage for the keyword arguments. As you can see, this is another way on how to pass the values to the function. Now, if you think about the readability and understanding, of course, the keyword argument's gonna win, because it is really easier for us to understand and which value belong to which parameter. It is really clear. The E is a country, first name Maria, last name Smith. But if you go over here, you have always to keep your eye on the definition. So you're gonna say, okay, of course here it is wrong. Let me just make it correct. So you're gonna keep mapping in your eye. Okay, so the first value is the first name, the second is last name. It is not that easy to read. So the keywords for the readability, it wins, as well for the safety. So of course, if you have a lot of parameters, we are all humans, we're gonna make mistakes. It's gonna be more safe if you use the keyword arguments. But here we come to the annoying point about the keyword arguments. It is way more effort to write it. So I have to keep writing the parameter names each time I'm writing the call. And of course, the maintaining gonna be really bad if you go and change things like in the definition. You say, you know what, I will just remove the name. I will make it only first. So I'm changing the name of the parameter. I changed my mind. So now not only I have to change things inside the function, I have to go for each call and start as we're renaming the parameter. This is a lot of efforts. And now, of course, you might ask me, which one should I use, positional or keyword? Well, this really depends on the number of the parameters. The rule says like between 2 and 3 parameters, it is totally fine to use the positional arguments because you can manage it. It's only 3 and I hope you will not make mistakes. But if you have more than 2 or 3, then you should go with the keyword arguments. It is just more safe because things gonna go out of your hands and you will not be able always to maintain the correct order for the arguments. So if you have 1, 2 parameters, go with the positional. More than that, go with the keyword arguments. And now to the next point, actually we can go and mix things. So you can go and use both of them in one call. So we call it the mixed arguments. Now, how are we going to do it? We can say clean name. Now, the first one going to be the positional argument. So it's going to be Maria, but let's make it like with spaces and stuff. And then it is followed by a keyword argument. So here's going to be the last name, going to be Smith, and then a country. So now if you go and execute it, you will not get any issues and it's gonna work. So actually you can go and mix it, but there is like rules to do that. So the rule says you cannot start with the keyword arguments. So for example, I cannot go and say, you know what, first name equal, and then followed by a positional argument. So without any name for the parameter, if I go and execute it, I'm gonna get an issue. It says positional argument follows keyword arguments. So this is the rule. You have always to start with a positional argument and then the keyword argument. And of course you cannot go and alternate between them. So you start with positional key and then the last one you say, okay, go back to the positional. You will get an error. So the rule is very strict. And of course you can go and start with 2 positional arguments and only the last one, it is keywords. So this is of course totally fine. Now you might tell me, but why we should do this? Why should mix the arguments? Well, the main reason why you would do this, it is just like styling thing. The thing is, if you have a lot of values, sometimes we have like primary values, the most important one, and then we have like secondary values that are helping the context. If I look to this example, I'm gonna say, you know what? The first name and the last name, those are the primary values. So this is the identity of the person and the most important thing in, let's say, the function. But the country, it is something like secondary. It is like a context, extra details about the person. So for example, if you have like a phone number or an email, all those informations are secondary to the main important information, the first and last name. So it's just like styling thing, a luxury thing to understand what is primary and what is secondary. But from my point of view, I would not go with this mixing because it might confuse later as you like change things. Either go with the positional and the keywords, and I told you about the rule. 2 parameters, go with the positional. More than that, go with the keywords. If you want to do things more fancy, then maybe try the mixed, but I don't recommend you. So now my friends, as you see, all the parameters that we use so far, they all require the value, and if you don't specify value for it, the code gonna break. But the thing is, in real projects, this will not work because sometimes we have parameters that are not that important, or let's say we don't have a value for it. That's why in Python we have something called a default parameter. A default parameter is a parameter that has only a value. If you don't pass for it an argument, a value, Python gonna go and use this default value, and this gonna make our parameter optional. So it is totally okay if I don't pass for it any argument, any value. So let's see how this works. Okay, so now by looking to our example, what could happen is that you have some registration form and you have some optional fields, like for example, the country information. It's totally up for the user whether they enter their country or not. And if they don't enter the country, the code, the program should not break. So that means we have to go and add a default value in case we don't have in the call the country, and we can do that in the function definition. So what we're gonna do, we're gonna go to the parameter over here and add for it a value. Not only the parameter name, but as well a default value, like for example, NA, not available. So that means, my friend, it is very simple. If you see a value inside the definition, then this value is actually the default. So now if I go and execute it, as you can see, we have always at the end DE, because in all of those calls, I'm specifying the value of the country. So that means it is unnecessary for Python to go and use the defaults. But now if I go and let's say, I'm going to call it here default, and I'm going to say here clean name, specify the first value, maybe Kumar and Suresh. Now, the last thing, the country, I will leave it empty. So I hope this is the correct order. But now I will not give the value for the country. So I'm passing here 2 values, but we have 3 arguments. But again, this is totally fine because we have a backup. We have a default value for the country. Now, if I go and execute it, as you can see, we're going to get Kumar Suresh from NA. So this time we didn't get any syntax error because Python has a backup. It has the default value to be used. So actually, it is very simple. Now, of course, things going to get confusing if you do this. Like, for example, you go and remove the default from the country and you give a default for the last name. Like, for example, I'm going to say, if we don't have a last name, then NA. Now, if you leave it like this and then you go and execute, it will not work because it says parameter without a default follows a parameter with a default. So actually you have to pay attention for the parameters. First, you have to list all the parameters without a default value, and only after that you list the parameters with the default. So that means you cannot mix it like this. Have as well to go and now add a default for the country. Otherwise, of course, Python will not understand how to map all those things. Now, if I go and execute it, I'm going to get the same results. And now, even if I don't have the last name and then execute, Kumar NA from NA. So this is totally okay. So that's it actually. This is what we mean with the default parameter. Alright, so now we're going to talk about something that is a little bit more advanced. So far, we defined exactly the number of inputs for our function, but there are some scenarios where we don't know in advance how many values we're gonna pass to the function. And exactly for that, in Python, we have 2 tools. We have the star args and the double star kwargs, keyword args. So what this means? So the star or the double star args, they're gonna allow our function to accept any number of arguments. That means it's gonna make it totally flexible. We can send for it 1 value, 2 value, 3 values. So now since we have those 2 types, positional and keyword arguments, that's why we have the 1 star args for the positional arguments and the 2 star kwargs for the keyword arguments. So now let's have a very simple example to understand how this works. So now let's say that I would like to make a function that calculates the total of multiple values. So we're going to make a function called total. And let's say that I want to pass for 2 values. So I'm going to go and define 2 parameters for that. And then I'm going to say print a plus b. And actually that's it. So let's go and call it total. And let's pass the 2 values 1 and 2. So now if you go and execute it, it is very simple. It is just adding the values. But now let's say that I would like to go now and add 3 values. 1, 2, and 3. Now, since I have 3 values, I have to go and extend my function and add for it another parameter c. And then as well go over here and say plus c, and then go and execute. Of course, we're going to get an error because the first call will not work. And that's because we have here only 2 values. And now in order to make this works, we have to go and add a default value for each parameter. So if there is no any value, it's going to be 0. Same things for the first one. And let's go and put everything with the defaults. Now, if I go and execute, it's gonna work. So for the first call, it's gonna be 3, and the second one is gonna be 6. Now, guess what? We're gonna go and add another value. So 1, 2, 3, 4. Now things will be really annoying because I'm gonna go and keep adding for each value a parameter and as well a default value. As you can see, this is not really smart. We don't know exactly what's gonna happen next. Are we gonna get like 5 values, 10 values? Are we gonna go and guess the number of parameters here? So now in order to solve this scenario, we have actually 2 options. The first one, we can go actually and pass a list. So instead of having like separate arguments, we're gonna send only one argument, one value, a list, and then we're gonna do the sum operator inside the function. But of course, this is gonna feel heavier because you have to go and create a list and stuff like that. That's why we have a second option where we're gonna use the star or the double star args. Now let's see how we can do that. The syntax for that is very simple. Now instead of having all those parameters in the definition, we're gonna go and remove them, and this time we're gonna say star and then args. And with that, I'm telling Python you need to accept any number of arguments. Of course, we have to talk about the definition of the function. We don't need all those stuff, the parameters, we don't have them. Now we have only one thing called args. So what is actually args? We can go and check that. So if you go and say type and they say args, let's go and execute it and check the type. As you can see, it is the class tuple. So that means, my friends, Python is collecting the different values inside the data type tuple. And now we can use any function or methods on this tuple like we learned before. So what we're going to do actually, we want to summarize all those values. We're going to use the function sum and we're going to pass for it our tuple. It is very easy, right? Let's go and try this out and execute. Look at this. We are getting exactly the same results. So it looks clean, and as well, we can go and pass for it any number of arguments. So I can go and say 1, 2, 3, 4, 5, 6. And if I go and execute, it's gonna work without me going and extending the parameters. So my friends, it is totally flexible and as well clean. So now we have to understand one thing: when to use the one-star args. If the values that you are passing to our function has always the same type of information, like here we have a list of numbers, so all of them are numbers, or maybe we have like multiple characters, multiple string values, then we can go and use the one-star args. But if things gets more complicated, where we have multiple type of informations that we want to send to the function, and for this scenario, the one-star args will not be enough, we have to go and use the two-star args. To have an example to understand what this means. So now let's say that we are building a function that creates the user profile. So we're going to go and define, for example, a function called create user. And now, of course, here comes the magic. If you want to have things flexible and you accept any type of information to your function, then we're going to go and use the double stars and then say kwargs. Then, of course, double point. And here we will not go and create anything. We're going to go and just print it. So we're going to go and print the kwargs. So this is the definition of the function. I'm just recording this again because some audio issues. Now, of course, the first step is that we're going to go and call the function. So it's going to be create user. And now, of course, we have to pass the arguments, but it should be a keyword argument. So that means key values. Like, for example, this time I'm going to say first name equal, like, for example, Mo. And let's have a last name like Salah. He's just the best, right? Now his age, I believe 33, right? Well, of course, depend on the recording time. And the country gonna be Egypt. So now those are the information about our user. As you can see, we have different things. We have names, we have age with number, we have the country. And what's gonna happen now, we're gonna go and send everything, the whole thing, to our function. But now before we execute the whole thing, I would like to see the data type of the kwargs. Is it a tuple? I don't think so. So let's go and print type the kwargs. Now let's go and execute the whole thing. Now look at this. The data type of the kwargs is not a tuple, it is a dictionary. And this of course makes sense because we are using the keywords argument, and this is key value pairs, right? And it is the only data type that can hold those informations. And now as we are printing, as you can see, we are getting the whole dictionary. So now this is one user. Of course, we can go and call it again, but we can use completely different setup. Like for example, instead of saying the first name, we can go and use a name, and this time I'm gonna say Ronaldo, and then we will not use any last name. We're gonna go and have only the country, so Portugal. So we don't have the age, we don't have the last name, and it is only two keyed arguments. So if you go and execute it, it's gonna be totally fine. Python gonna go and collect those two, put it in a dictionary, and then print the whole thing in the output. And of course, you can use the kwargs only if you are using keyword arguments. So for example, if I go over here and just remove the whole thing, so I have here positional argument and execute, I'm gonna get an error. So this will not work. So Actually, that's it. It's very simple. This is how the double star kwargs works. So now let's go and recap and compare them side by side. The 1-star args accepts multiple positional arguments, and the 2-star args accepts multiple keyword arguments. So you have to include as well the name of the values. We use the 1-star args if we are passing the same kind of informations. So we either sending numbers or we are sending string values. But if we want to mix them and send multiple pieces of informations, then we use the double star kwargs. And now about how Python stores those informations, the 1-star args stores the data inside a tuple, and the 2-star args are stored as a dictionary because it has to store the key value pairs. So actually that's it. This is for those two tools. It is not that hard. Now, so far, all what we have talked about is how the data gonna go inside our function using the parameters and the arguments. So this is actually one shape of the functions, but of course we can go and extend it where we build an output from the function so the data goes outside the function. And of course we can do that using the keyword return in order to return something back to our program. So now by looking to this is the most famous shape of functions. We call it the transformation function because it works like this. We send the raw values to the function, so data goes in, then something gonna happen to the data. So the data gonna be transformed to a different shape, and then this data gonna comes out and return back to the program in order to do something else with it. So it sounds very simple, and most of our functions looks like this. Now if you look back to our example, you can see actually we are just printing the output of the function, and of course printing it is something for us, for human. We are seeing the text in the screen. But the thing is, programs don't work with the printed outputs. They need the function to return the values back to it internally, and for that we have the return. So that means if you want the result of your function to be reused later in the program, you cannot use print, instead you have to use return. And of course you can use both of them if you want to print something for you and return something back to the program. So now of course let's have a look to the syntax. Now we have to change both of the component, the definition and the calls. So now for the definition we're gonna go to the end of the function and we're gonna add the keyword return. And after that, very important, you have to add something. You have to tell Python what to return. You cannot leave it empty. So it could be anything, a value, a local variable, a parameter, calculation, logic, or maybe calling another function. So anything after the return, it's going to be okay. So now by looking back to our example, I'm going to go and remove the print, and instead we're going to put a return. And what we are returning here is the local variable, the final result of the calculation, return y. Now about the call, we cannot just go and call the function and walk away. We have to store the returned value somehow, right? And of course for that we usually use variables, then assign for it the function call. So now whatever the function returns back, it's going to be stored inside this variable. And of course this is amazing because now we can go and do something for this output, like maybe go printing it or do something else. So now let's understand how this can be executed behind the scenes. So as usual, Python gonna execute it from the start. We're gonna go and define the function without executing it by creating the object function in the memory where we have inside it the name, the body, parameters. So that's it for the definition. Then Python gonna go to the next line where we have the global variable and the call. Now since we don't have the value yet, Python gonna go and execute the right side. So it's gonna go and execute the call by first assigning the argument to the parameter, and then it's gonna go inside the body and start executing it step by step. Here we have a local variable and an expression. So it's gonna go and grab the parameter value, multiply it by 2, we're gonna get 6. And now Python gonna go and create a local variable y and assign for it the value 6. Then Python gonna go to the next line, and here it's gonna see a return. And after that we have the variable. So now Python gonna go and grab the value of the local variable y, so the 6, and then it's gonna send it back. It's gonna return it back to the caller, so that we have z is equal to 6. But of course before doing anything else, it's gonna go and clean up. It's gonna go and destroy the local variable and assign the parameter. Now we have everything, and with that Python gonna go and create the global variable, the z, and assign for it the value 6. And now we can reuse it as we want. So for example, we go and print it. It's gonna grab the value from the memory and put it in the output. So now my friends, as you can see, you have now the full big picture on how everything works together. The input, the arguments, the local variables, the global variables, the output, the return, and it's pretty easy, right? So everything makes sense. But there is one small thing before we go to practice. Actually, in Python, if you don't specify a return, still Python gonna send something back to the program, by the way. And you might say, what you are talking about? Well, it's gonna send something called none. And of course, none, it's not a real value. It's something unknown, missing. It's not a useful information, but still it is an indicator that the function is not returning a real value. And this is something, of course, we can use. So if you are not defining a return, Python gonna send a none. But if you use a return, it's gonna send a useful information back. Okay, so now, of course, let's go and practice. Okay, so now by looking back to our example where we are sending a row data, the row name, and then we are cleaning up the name by removing the spaces and as well making the case lower. But now the thing is, I'm just printing the value in the output and that's it. And this is not something that we usually do in projects. Usually we do a step, we cleaned up the name in order to use it in the next steps inside my code. So by leaving it like this, I'm losing this cleaned value in my program. So that means we have to return this value. So our example is more realistic. At the end, we're gonna go and say, you know what, go and return the local variable that holds the cleaned value. So I will go and remove the print. I don't need that. If I leave it like this and execute, nothing gonna happen. Everything is lost. The program is not getting the returned value, and me as a human, I'm not seeing what is going on in the output. So of course, in order to capture the return, we have to go and add a global variable. So let's go and add a variable called clean name equal, and then assign for it the whole call. Now, let's go and execute it. Of course, we are not seeing anything because we are not printing, but at least my program is getting something back. Now I'm going to go and print our new global variable. So the clean name, as you can see, we are getting Maria. So not only me, I'm seeing the value, and as well, my program is storing the output of this function. So actually that's it. I'm really happy about the example. Now it looks perfect. Data goes in, we do transformations, and then we return the data back. Now I would like you to test something, like for example, I will remove the return. So my function is not returning anything, but still I'm trying to catch something from our function. So if I go and execute it, as you can see, we are getting none. So if you are not using a return, Python gonna send the none, it means nothing, back to the caller, and then it's gonna go and assign it, of course, for the variable so that you can see none. All right, now next, one more scenario about the return. Actually, we can go and use multiple returns inside the function definition. So let's have an example. You remember if I go and remove everything here from the arguments and say I would like to send an empty string. Now, if I go and execute it, what's gonna happen? I will not see anything in the output because it is an empty string. But now dealing with empty string, it is something really annoying. We usually convert the empty string to a none because it is easier to handle and it makes everything more clean. So what I'm going to say, I'm going to extend the logic and say if the name contains an empty string, then replace it and return a none. Otherwise, if you have a real value, then go and do all those steps. That means there is like a logic, there is a conditions, right? Let me show you how we're gonna do it. So we're gonna say if, and then say not name. So if there is something wrong with the name, it's not a real value. Like here, what's gonna happen? Don't do anything, just return a none. So that means I'm not returning the value empty string, I'm just returning none. Otherwise, if we have a real value, then actually do the whole steps. So I'm gonna go over here and say else, and of course we're going to put the whole logic inside it. So make sure you are working correctly with the indentations, and with that, look at this, we have twice the return. But since we have an if else, Python can execute only one of them. So now let's try this out with this empty string and go and execute it. Look at this, in the output we are getting none. So that means the if statement is activated. We fulfilled the condition of the if statement and it is returning the none. So we are not returning the name or the variable. Now if I go and say Maria like this and then execute, it is not fulfilling the condition because it has a real string value and it is going to the else. So it is processing the name and returning the process name. So that's it about using more than one return. Now there is another thing here, we are returning only one value, but actually we can go and return multiple values. So let's have the following example. I'm going to go and get rid of the conditional statements and then we will have this code. Now in this example, we are always switching the names to lowercase. Now what could happen is that I would like to see my value in both lower and as well uppercase. So that means my function should now return the same value twice, one with the lower and one with the upper. So how are we gonna do it? I'm gonna go over here and say, okay, this is the low, and now I'm gonna go for the upper, cleaned, equal. Now either keep working on the original value and say, you know what, we're gonna strip it again and say here an upper, or you can go and take the lower and switch it to an upper. So this is the transformation, and with that I have two local variables. Of course I have to go and now return them. So I'm gonna say lo cleaned. This is for the first value, and then in order to put another value as usual, we use the comma cleaned. So that's it. I'm returning now multiple values back to the caller. Now the caller should be responsible and as well receive both of them. If I leave it like this and execute, I'm getting in the output now a tuple of both of the values. Of course, you can go and check the data type of the returned value. So this is a tuple, but if you'd like to get like the returned values in two separate variables, all what you have to do is to make as well a list of global variables. So the first one I'm gonna say low name, and the second gonna be up name. So with that I will capture both of them, and of course I can go and print both of them as well. So low name and up name. So that's it. Let's go and execute. Look at this. I have two values. They are not in the tuple anymore. They are just normal string values inside my two variables. So this is how you return multiple values in one go back to the caller. So my friends, as you can see, we have different shapes of functions for different purposes, and you can see how the data flows inside the functions. So data goes in, maybe goes out, and of course this depends on the scenario. So again, by looking to this, we could have a function that is just a block of code, nothing goes in, nothing goes out, or we could have a function that takes one input using the parameter and the argument, or another shape where you have a function that as well has an output, so it is returning something back to the program. That means data goes out. As well, we can have like multiple outputs, so we are returning multiple values back to the program. So my friends, you have the full control on how to design your function by using the parameters, arguments, and return. So you have the full control on how the data gonna flow inside your function. So now, so far we have learned all the different types of Python function, but based on how the data flow through the function. But now in real projects, we categorize and classify the functions by something else, by the purpose. We classify them based on the job each function is responsible for. So now what we're gonna do, I'm gonna show you some famous patterns and function types based on their purpose and the use case. So now, let's go. Alright, the first type is the action functions. It is a function that does something in the system instead of returning a value. So action functions, they are actually focused on side effects. They change something outside the function. Like for example, a function that is printing something on the screen. Or very famous one in data engineering where it saves data to a file or to a database, or you might have function that is actually sending emails and notifications if something goes wrong. And another one could be maybe calling an external API. So as you can see, all those action functions, they don't deal with values and data, but their job is to do something outside the function as a side effect. But sometimes different developers in different projects use different names, like side effect function, command function, handler, service functions. All are different names, but for the same idea. So now let's have a very simple example. Let's say that we want to store the application log messages in a file, so that every time an event or something happens, we're gonna record it and store it inside the file. Of course, we didn't talk about how to deal with files inside Python, but this is a very simple one. So just follow me step by step, it's gonna be easy. Okay, so now let's see how we're gonna solve it. We start with the diff as usual, and then the function name, we're gonna call it write log. And now for the input, the parameter gonna be the message, so we need it in order to store it inside the file. Now, in order to work with files, we're gonna start with the keyword with. It's gonna help us to open a file, use it, and then save it automatically and safely. So with open, and now we're gonna specify the path of the file. Now, of course, depends where you store your files. I'm gonna go and put it like this. So it's gonna be in C, and then backslash. I'm gonna put it in main, then Python, And then I'm gonna call the file app.log. So now, since we are using here a lot of backslashes, I'm gonna go at the start and say an R to tell Python, actually, this is a string. This is not the special character backslash. So it doesn't mean starting a new line or do something like special. It is just part of my path. Now, after that, we're gonna say comma, and we're gonna tell Python how it's gonna go and store the information inside our file. There are different modes. We're gonna go with the A. So we are telling Python, go and append my messages to the end of the file. So don't go and delete anything or update anything. We always go and add things to the end of the file. And then we're gonna say as file, so that we can write to the file, then double points, so a colon, and then another enter. Make sure the indentations are correct. Now we are inside this statement. So now what we're gonna do, we're gonna go and write something to the file, right? So what we're gonna write inside the file, it's gonna be the messages. So it's going to be our parameter. And now, since I would like to see each message in a new line, I'm going to go and add a plus and then a new line. So \n. So again, what's going to happen? Python going to go and create a file called app.log inside this path. The mode is append, so it will not delete the data inside the file. And then what is the action? We are writing inside the file by adding the parameter message into a new line. So actually, it is very simple. That's it. Now, let's say our program runs at the start. So we're going to say the app started. So this is the first event. Now, what we're going to do, we're going to go and execute it. So now, if you get it like me, without any errors, that means it was successful. Of course, I'm not seeing anything because we are not printing anything in the output. And in order to check our results, we're going to go to our file, right? So I am inside this folder and I can see the app.log. Now, let's go and open it using any editor that you have. So now, look at this. Inside it, we have our message stored inside the file. And this is exactly what we wanted. Now, if you go back and then over the time something else happens, so we're going to write inside our log user logged in. So this is the second message. I will just comment this out. Let's go and execute it. Now let's recheck our file. Look at this. We have the second message appended. So it is something added to the end of our file. User logged in. Let's go and add a third one. Of course, I don't want this to be repeated. Let's write log app stopped. So we are at the end of our program and I go and execute it, and then reopen the file. You can see the last message, app stopped. So now, as you can see, my friends, it is really easy now to deal with the logs using this nice function where it does one action. It go to my system, open files, and write the message at the end. That's why we call it an action function. Moving on to another type by purpose, we have the transformation functions. We already saw that previously. It is a function that takes raw data as an input, then it does some transformations and data manipulations on it, and at the end it returns a new value with a new shape. And now, of course, about the transformations, we could do a lot of things, like calculating new values, transforming a text or structure, converting from one format to another, extracting or reshaping the data. So our logic could be anything that manipulate our data. So it's not about like changing the system or like interacting with something outside the function. It's all about changing the shape of your data. And of course, in any data projects, engineering or analytics, this is the most important shape of functions that you have to learn, because it's going to contain the core business logic that can manipulate the data. And of course, developers in different projects use different names like the data functions, calculation, utility, mapper. So again, different names for the same purpose. Okay, so now let's have the following task in order to practice. Our task is to clean the email addresses and split it into structured data. So that means we have to return the username and the domain out of the email. So let's see how we're gonna do it. Of course, as usual, we start with the definition. The name gonna be clean and split, since we are doing two things, the email. Now about the inputs, of course, we just need only one thing, the email. So this is our parameter. Now let's go inside. I'm gonna say the first thing, that's to go and clean the email. So I'm gonna put it in a local variable. And usually we clean it by removing the extra spaces. And maybe as well by normalizing the string value to a lowercase. So just standard things, we already done it before. Now, of course, our task gonna say split it into username and domain. Just to have an example, let's say that we have sarah@gmail.com. So that means Sarah is the username and the gmail.com is the domain. That means we need two informations, and for that we're gonna have two variables, username and the domain. Now, how we gonna extract those two informations from one string? Do you remember? We used the method split. So it is very easy, and of course we have to tell Python where exactly it's gonna be splitted. It's gonna be at the @ so that Python gonna go and extract everything before and after the @ and return them as two values. Now, actually, that's it. All what's left is to go and return them. So of course you can go and return the username and the domain separately, but our task says we have to return it as a data structure. So that means we have to put those two variables into one data structure, and you have to decide on which type. Of course, since we have here two different type of informations, we have the username and domain, we're gonna go with that dictionary. So it's gonna be very simple. We're gonna use the parentheses, and we need key values. So at the start, we're gonna say username, double points, gonna be the username, and I would like to start a new line. The domain, gonna be the value from the domain. Actually, that's it. Are taking the email address, we are cleaning it up, we are splitting it into two informations, and then returning it as a data structure. Of course, we have to go and test. So we're gonna call the function, and let's have Sarah gmail.com. Now, of course, if I run this, I will not get anything in the output. I would like to see the results. So what we can do, we can either assign it to a global variable or just go and print it actually. And that's it. Let's try this out and execute. Now look at this. We are getting our dictionary. Everything is splitted. But I would like to go and test. Like, for example, I'm going to go and add here space, and at the end as well space, and maybe write everything in capital letters, and here as well. So let's try this out. As you can see, even if I have bad data, I'm still getting clean data in the output. So it is actually working. So as you can see, my friend, this is a typical transformation function. It takes data in. So the email is the raw data. Then some transformation gonna happen and data cleanup. So we are manipulating the data and we are returning the result, the new shape of the data back to our program. Okay, now we have a third type of function. We call it the validation function. It is a very simple function that's gonna check whether something is valid or not. And typically this type of function gonna return a boolean, so either true or false. So my friends, the validation functions are actually focused on the rules and the correctness more than changing anything. Like, it will not change your data or your system. So there is actually no action. You have a very simple question, and this function can answer your question by either yes or no. And this is very useful for many scenarios, like for example, validating the user input, checking whether the business rules are correct, verifying the data quality, and something that I use a lot, we're gonna use it in order to check whether the user has permissions or not. And my friends, in real projects, the validation functions are really important because usually the data has bad data quality, and you're gonna use those functions to protect your system from bad data. And as a data engineer, as you build your data pipeline, you're gonna as well write a lot of validation functions to protect the data before inserting it. So this is something really important and we use a lot in real projects. Now, about the names, basically we call them validation functions, but you might hear of maybe a checker function, but they are all the same. Okay, so now let's have this very simple task to practice. Check whether the passwords meets the minimum length of 8 characters. So of course, this is gonna be easy as well. We're gonna start with def as usual. And now since this is a question that we're gonna ask our function, we usually write the name as a question as well. Valid password. It sounds like question, and it's gonna be really easy as well to understand this is a validation function by the name. And of course, about the input, we want to send our password. And now we're gonna go inside the function. So now we have to calculate the length of our password. And for that, we have our nice function, the length. It is a built-in function, and we pass for it the password as well. So with that, it's gonna return the total number of characters of our password. And now, of course, we have to check the length. That's why we're gonna go and say it should be longer or equal to 8. This is the minimum length. Now, of course, this expression like this, it's gonna return either true or false. So this is a condition, and actually we can return the result of this condition like this. So it is very simple. We are returning the result of our check. So actually that's it. So we're gonna go and test it. So is valid password. And now just go and through any password. So yeah, 1 2 3 4 5 6. And of course, in order to see the results, we're gonna go and print the whole call. So let's go and execute it. Now look at this, we are getting false. We are not fulfilling the requirement because this is only 6 characters. So now, of course, let's try a valid one. I'm gonna go and add 7 8 and then execute. Look at this, I'm getting it true. So as you can see, my friends, this function is not transforming anything. My password gonna stay as it is. It is just answering a very simple question. Is the password valid or not? So the answer gonna be always yes or no, true or false. Okay, so now let's have another task. It says check if an email address has a basic valid format before we use it. So this is a very typical thing that might happen. The user is just registering and giving us the email. Sometimes they make mistakes and we're gonna get bad data. So now before we start using the emails, maybe to store it or to analyze something, we have to check is the email valid or not. And for that, we can write a very nice function like this. So now since we are checking something, we're gonna call it as well as a question. Is valid email? And of course, what is the input? It's going to be the email address. Now, one of the typical things that might happen is that the user might forget to add the @ This is very critical, of course. So we're going to say, is the @ in the email? So this is the first condition. And as well, very important structure is the dot. So .com, .net and stuff like that. So I'm going to say as well whether the dot is inside the email. Now, of course, there could be a lot of scenarios, but this is the basic checks. So now we are saying, is @ in the email? Is the dot as well in the email? If both are true, then of course we're going to get true. But if one of them is false, we will get false because we are using the AND operator in between. So now this is our expression, and what is left, of course, we have to return the result of our check. So actually that's it. Let's go and try this out. So is valid. Now I'm gonna write a bad email like sarah@gmail.com without an @ and of course we have to print. So let's try this out. As you can see, we are getting false. This is not a valid email. But if I go and add for it an @ in between, look at this, I'm getting true. So this is a valid email. We can check another scenario where we don't have a dot, we are getting false. So both of the conditions should be fulfilled, the dot and the @. And of course, if we don't have @ and dot, we should get as well false. So as you can see, I'm just asking the function over and over, and all what I'm getting is yes, no, yes, no. So this is something that you're gonna do a lot in real projects, where you're gonna check the data before doing anything. Alright, my friends, so now we're going to talk about my favorite and the last type of functions based on the purpose or the use case. We have the orchestrator functions. An orchestrator function is a function that controls the flow of your program by calling other mini functions in the correct order. And that's why we call it an orchestrator function, because it is focused on the coordination and not about the logic or calculating the data or changing anything. Their main job is to connect everything together and to decide what is the next step to be executed. That's why in real projects, you're gonna find mostly in those projects like a little logic that gonna decide based on some condition what is the next step to be executed, what is the next function to be called. And this is why I love those type of functions, because they represent a process, a workflow, and it makes it really easy to understand your whole program in a very high level. So those are amazing type of functions, and I can tell you, once I enter a new Python project, I always go and check the orchestrator functions to understand the behavior and the steps of the whole project. Now, of course, about the names, it could be orchestrator or workflow functions, controller, pipeline, coordinator. Again, different names for the same purpose. All right, now in order to practice this type, we can have a mini project. So we have the following requirements. We have to build an application. We're gonna receive an email from a user. We must check if it is valid email. If it is not valid, we have to log the problem in a file. But if it is valid, then we have to clean it and store it in a data structure. And of course, we have to log each step of the program. Okay, so now let's see how we're gonna do this project. We have already solved a lot of parts, like for example, logging the messages, we have the validation, we have the cleaning and splitting. So that means we have already some random function solve part of the puzzle. What we have now to put everything together in a process, in a workflow. So now those are the steps. And the first thing that we have to do is actually, we want to receive an email from a user. So let's say that I'm gonna ask the user in an input to give me the email. So I'm gonna say the email gonna be equal to the function input. And we're gonna say, please enter your email. So with that, we're gonna get the email from the input and we're gonna store it inside the global variable email. Now let's go to the second step. We must check if it is a valid email or not. So we already have a function for that, is valid email. So what we're gonna do, so that means we're gonna call the function is valid and we're gonna pass for it our email. Okay, so now this is the first step. Now the second step, it says if it is not valid, we have to log the problem. So that means there is some kind of condition that I have to do first. And if it is fulfilled, then I have to write a log. Of course, we have already a function in order to write a log in a file. But first we have to build the condition. So we're going to say if is valid. So the same thing. If it is not valid, that means I have to go and use the not operator. So if it is not true, what's gonna happen? We're gonna log the problem. So we're gonna call the function write log, and what it needs actually just a message. So I'm gonna put the whole message with the email address as well. So I'm gonna say an if in order to combine the message with the variable email. I'm gonna say invalid email received, then double point, and then after that double point, and of course our variable, so the email. Okay, so now let's go to the next step. It says if it is valid, we clean it and store the structured information. We're gonna say else, and now we're gonna call the transformation function. So clean and split the email. So we're gonna pass for it, of course, our email address, and actually that's it. So this is gonna happen only if the email is valid. So as you can see, this is how the two types of functions works together. First, we validate the email. So we are using validation function. And if everything is okay, then we use the transformation function. Very, very typical. Now, the last step, it says we have to log everything that is happening. So that means we have to log the start, the end, whether it was successful or not. Now, if you look to this, we just logged if something goes wrong, right? But still, I would like to log as well if it went successful. So I'm gonna say, after cleaning, go and write in the log something like processed email. And then actually, I would like to print the result of the cleanup. So that means I have to store the returned value from the function in a global variable, like for example, clean email equal. So I'm assigning the return into this variable, and then I'm gonna print it in the logs. So I'm gonna say clean email. So with that, we have as well a nice information inside our log about the processed email. Now, of course, we can go and add some extra informations, like for example, at the start, we're gonna write in the log like application started, and completely at the end, we're gonna say application is stopped or ended, and it looks now like a workflow, like a process. So our application gonna start. After that, we're gonna get the email from the user. Well, actually, this is unnecessary, so let's remove it. We're gonna validate it over here. If it is not valid, then we're gonna write an issue inside our logs. But if it is a valid email, so everything is correct, then we're gonna process the email where we're gonna clean and split, and then we're gonna print it as well inside our log. And at the end, we have a nice message that everything stops. Now let's go and try this out. So I'm gonna say, let's start with a valid email. So sarah@gmail.com, everything is correct. Let's go and execute it. Now look to our log, everything looks nice. So the app is started. We processed the email, so we have the structure. We have the username and the domain. Everything was okay. And then the app stops. So with that, I have a nice protocol of how things worked. Actually, it looks nice. Now let's go and try the invalid email. I'm gonna say just remove all those informations and save again because it's gonna be appended. Now let's go and run it again, and sarah@gmail.com. So we don't have an @ and then execute. So if you look to this, we can see the app started, stopped, but we received an invalid email. So actually that's it. Our program is ready and everything is correct. But now you might say, but wait a second, where is the orchestration function? Of course, you are totally right. All those steps are actually the preparations for the orchestration function. Now look to the whole code over here. You can see we have our functions, and now we have the whole workflow outside the functions in the body of our program, right? And this is a process calling the other functions. Now what we can do actually, we can put the whole thing inside a fourth function. So here we're gonna have our orchestrator function. And as usual, we're gonna start with a def, and then we're gonna say process user email. And now about the input here, we have like two options. Either we're gonna leave it empty because we are getting the email from the input, or we take only this step outside and we send to this orchestrator the email. So I'm gonna go with the second option. I'm gonna take this step completely outside and just put it here at the end. So now the orchestrator gonna get an email, and everything else gonna go inside the body of the orchestrator. Let me just clean up a little bit those comments. I'm gonna put it over here. So look at this. This is exactly the purpose of the orchestrator. It is calling all the other functions. So we have here the write log, is valid email, the transformation, and it is in the correct order. So that means first we have to validate, and then we're gonna clean up if everything is correct. And as well, it is controlling the flow of the program. So it has its own like if-else condition, right? And this is exactly the purpose of the orchestrator function, to call other things. Now, all what we have to do in the body of our program is just calling this one function, and it's gonna do the rest. So we collected already the email, and then we're gonna say process user email, and I'm gonna pass for it the input from the user, and that's it. So now, as you can see, the body of our program has only 2 lines of codes: get the data and process it, and everything else are actually inside functions. So now, of course, you can go and test those stuff. So if I provide clean data, it's gonna work. So again, app started, processed email, and app stopped. So my friends, this simple program is a real world scenario that we usually do at projects. And as you can see, this is the mindsets. We split the functions actually by the purpose, by the use case. Once I start writing a new function, I will think, is it like transformation? Is it validation? Is it an action? And then after writing many different functions, we put all the puzzles together inside one orchestrator. And with that, now we have a feeling, a real understanding how we use functions in real projects. Alright friends, so with that you have learned the different types of functions based on the purpose, on the use case perspective, and now you have more understanding on how we use functions in real projects. So again, the first type, the action functions, they make things happen. So they interact with things outside your program, your system, printing, saving files, calling an API, or another very famous form, the transformation function. They work with your data. So they take input in, they change it, and then they return a new value. Another use case, we have the validation function. It checks the rules. So it's gonna answer your questions with either yes or no. You're gonna use them a lot in order to protect your system and to check the quality of your bad data. And the last one, my favorite one, the orchestrator function. It's gonna go and connect everything together by calling other mini functions in the correct order. And once you understand those patterns, it's gonna be really easy for you to design your program, to write the code, and to maintain it. So those are the different types of functions by the purpose. So now we're gonna start with the first step, where we're gonna learn simple but yet very powerful rules that every Python developer should follow when they are writing functions. The goal is very simple. We have to write code that is easy to read and easy to understand, not only for you but as well for your colleagues. Many of those rules are actually come from the pip 8. This is the official style guide for Python. Just Google it and you're gonna find there like a lot of rules that are considered as standards on how to write clean Python code. Of course, we will not deep dive into all of them, but I'm gonna show you the most critical one that if you ignore it, your pull request in the review gonna be rejected. But at the same time, there are rules that are not written in the official document, but still it is like common standards between professional Python developers. So now, let's go and dive in. Alright friends, so now here we have a very simple example of a function that is actually working, but not following any standards. So if this is really bad, the function accepts 2 parameters. the price and the rate, and it does some calculations in order to find the price after applying the discount. So now what we're gonna do, I'm gonna show you how I usually review the code in my projects, and we're gonna refactor this bad function so that we're gonna apply all the standards and the rules that we usually follow in our professional projects. So now, usually the first thing that I look at is the function name. And here we have few rules. The first rule says, follow the naming convention, the snake case for the function names, where we use lowercase letters and we separate them using underscore. This is the official style from Python if you are following the pip8. So now by looking to the function name, as you can see, it is not following our standards. The D is uppercase and as well the P is uppercase. And the two words actually connected to each other. There is no separation. So there is no underscore. Now in order to fix it, we can do the following. So we're gonna say diff, and now everything is lowercase. So disk underscore, and then after that we have the print as well lowercase. So actually this is the function name following the first rule. Now the second rule is as well about the naming of the function. So it says a function name should clearly describe what the function does. So we usually start with a verb in the function name because usually our functions are actions and it does something. And always use clear names and avoid abbreviations. So now by looking back to our name, disk underscore print, it doesn't say anything, right? It is not an action. I have to check the function or maybe the description to understand what is going on, right? So now we have to give it a better, meaningful name. So first we're gonna start with a verb. By looking to this, we are calculating the discount, right? So the verb here is actually we are calculating. So calculate, this is the action name. And then we have to describe what we are calculating. It is actually the discounts. So this is the function name. It starts with a verb and all the names are clear. So now by just looking to the name, you can understand immediately we are calculating the discount. So if you go and compare it to the old one, it is way more clear, right? Now the next step, I usually go and check the parameters. And here we come to the third rule. Parameter names should explain what kind of value they hold. So it is very similar as well to the function name. Don't use abbreviations or like here single letters for the parameters. Just use a full name. It's gonna make your life and your colleagues' life easier. So now instead of having P, we're gonna say price. As well, of course, everything lowercase. And instead of R, we're gonna say rates. By just renaming, everything is clear. Calculating the discount, gonna need the price and the rates. But now if you read this, you can ask yourself, what is P? What is R? I need some catalog to understand how this works. Alright, moving on to another thing. After reviewing the name and the parameters, I usually go and check the description of the function. So where is the documentation here? This is really bad, and here we come to the rule number 4. Always use a docstring to describe what a function does. I know this is a topic at the start might sound annoying for many developers, but as you do multiple projects, you can understand why we document our functions. Of course, in projects, you will not be soloing Python. You're gonna work in a team, and it is always nice to let others know what the function actually does. And not only for them, actually for you as well. Because believe me, after a week writing your function, you're gonna forget about what you have written. So by having a nice clean description, it is as well good for you to remember what you have done in case you want to refactor or maybe to fix your function later. So now I said we use docstring. So what is that? It is a string that is placed at the first line inside the function. So this sounds a little bit weird. Let me show you what I mean. So this is our function here. And now I'm going to go inside it. The first thing that we do inside the function is actually not writing the logic and the calculations. We write a description. So in order to write a docstring so that it is easier for you to write like multiple lines of descriptions, but for now I'm gonna have it only like one line describing the function. So it is very simple. Calculate the final price after applying discounts. So actually that's it. This is only one line. And now you might ask the first question and you say, why we are putting this in a string? Why we are not just using a comment like we used before? So we start with the hash and then we put the whole thing. Well, the first thing is that once Python sees the hash, it understands it is a comment, and Python will gonna ignore the whole thing. So it will be lost, it will be ignored, and the program, the code, don't know about this comment at all. But if you are using a docstring, Python gonna use this as a description for the function. So it's gonna go and store it inside the function as documentation. So it is not lost, it is something that is attached to the function. And of course you might still asking why we need actually the description. We are not using this value, this string value inside our calculation, right? You are totally right, we are not using this as a value for our function, but it is there inside the program and I can go and call it. For example, if you go and use the function help and then use the function name, so something like this, Python gonna return the documentation of the function. But of course, in order to try this, I need something inside the function. So maybe return now 1, something like this, just in order to not get any error. So now if you go and execute it, now look to the output, I'm gonna get a full description of my function, including the docstring. So this is a really nice information and it lives and exists inside Python now. But if I don't do it, so let me just go and remove it and I stick with the comments. Look at this as I'm asking for help for the function. There is no documentations for the function. That means I have to open the code to open the function in order to read the comments. So this is something that we check whether the function has a description or not. Then we go inside the function and start checking the logic and how the function is written. And here immediately you're gonna jump to the next rule where we're gonna say don't print inside functions, instead use returned value. So now by looking to our function, actually it is printing a lot. We have the first print and the second print and it is not returning anything back to our program, and this is something that we have to avoid. So avoid using prints. So that means if I take the logic over here and start like refactoring, I'm gonna get rid of the first print as well. I understand it is nothing to print in the output, but we usually don't do that. If I need to print, I always print in the main code, not inside the functions. So I will get rid of this, and instead of the last print, I'm gonna go and replace it with a return, of course. And of course here we have to go and start using our parameter. So it's gonna be the price, and here the rate. So that's it actually. Don't use prints, use return instead. Okay, moving on to the next rule. Don't modify the values of the parameters. So leave it as it is. Use local variables instead. So now by looking to this example, you can see the parameter p is actually getting modified by assigning it to the new calculation. So with that, at this stage, actually you lost the raw value. So we don't do this. Instead, we introduced a new local variable. So now instead of saying price is equal, I'm gonna say final price. So that means the original price inside the parameter and the modified one is inside a local variable. So with that, I don't lose my values. And now I'm going to go and return, of course, the final price. Of course, at the end, I'm going to get exactly the same result. It's just like a clean way on how we work inside the function. Because as things gets more complicated, you might go and start like adding more steps and it will not be any more clear. Are we using now the original price from the input or is it like modified? So just make it clean and introduce a new variable. It will not be bad. So now the next one, it is not a rule, but if you have like one line calculation like this and you don't have any extra steps inside it, you can actually skip using any assignment and using a local variable. You can put the whole thing as an expression inside the return. Our function is just one line together with the return. So I'm gonna say this is not like, let's say, hard rule. It's gonna be okay if you use it like this or introduce like a local variable for it. Now I'm gonna say if you follow those rules, now you are 80% professional at your code, but you have followed all the must rules. Now we're gonna go and add some extra, let's say, add-ons, modern rules. So they are not described in the pip 8, but they are rules that are actually followed by professionals at companies. So now the first luxury rule says, use data type hints for the function parameters and the return values. Now the thing is, in real projects, most of the bugs comes actually from wrong data types. What actually happens is that if I am like calling the function and I understand, okay, it accepts a price and rate, but I don't know exactly which data type I should follow. Like maybe for the price, it's gonna be clear, I'm gonna use maybe 100, but for the rate, I might go and add like maybe a string value, like 20%. Now, if I go and execute it, I will get an error because this is a string value and it will not work in the calculation. It needs a numeric value, but it's something that I really don't know by just reading the function description or the function name. Of course, it is now very clear that I should not use it, but if the function is a little bit complex, you're gonna end up using a wrong data type. And this happens a lot in projects, really. So now instead of me try and error which data type I should use, usually the one that is building this function should give me a hint. So how are we gonna do it? We're gonna go to the price and we're gonna say double point after it. So not equal, I'm not assigning anything. Double point, I'm gonna say float. So now this is a very important thing to understand. This is a hint. This is for us, for humans, in order to understand how to do the call. It is not for Python. So Python will not go and change the data type of the price to float. The data type gonna be depending on the values that you are passing in the function call. So Python gonna see this is 100 and then it's gonna use for it maybe a number. So I'm not assigning here or doing data type casting. It is just hint for us. And the same thing, I'm gonna go and add it for the rate. So use a float. So that's for me as a caller for this function. I'm gonna understand immediately, okay, the rate should not be, let's say, string value, it should be floats or a number, of course, it's fine. So now with this, we gave hints, of course, for the parameters, the input of the function. But as well, we can go and give a hint for the returned value so that I understand, okay, I'm returning here a float number. But now in order to do it, we will not go over here and add a double point. Instead, we're going to go over here just before the double points. We're going to go and add a nice arrow and then we're going to say floats. So with that, we are saying this input can return a float. Like, it looks nice, right? So as I said, this is a luxury thing, but professional Python developers use those hints usually in the functions. Now, another luxury thing, but still it is professional, we add as well description for the input and the output inside the docstring. You're gonna find this everywhere from professional Python coders. So how are we gonna do it? We're gonna go and add a new lines inside our docstring. So now this is just a description. Usually the first one gonna be the description of the function, and then we're gonna say args for arguments. Now we are just describing the input of the function. So just organize it nice. We're gonna say, okay, the first input is the price and the data type gonna be floats. And here you just describe the input. So maybe you can say original products price. And then the second input gonna be the rate as well floats. So we're gonna say discount rate as numbers. Maybe I'm gonna go and add an example, 20 for 20%, something like that. So I'm just describing the inputs. Now, of course, we can go and describe the returned value. So we're gonna say returns, double points. We have here only one value, so the final price. So it's gonna be as well float, final price after applying discounts. So with this, I can say you have now professional docstring for the function, one line for the function description, for the inputs, so the parameters, and for the returns. So my friends, those two things, the hints for the data types and the extended docstring, it is something nice. If you want to work as an expert, you can go and add those small details. So now just have a look, go and compare the new design of the function with the old one. By adding those few rules, which is really simple, our function looks way more professional than the old one. And in just a few seconds, you're gonna understand exactly what is going on and you're gonna look professional at your projects. We're gonna talk about the Lambda. The thing is, in Python there are a lot of built-in functions that we could use, but sometimes you want to create your own custom logic, and we can use Lambda to do that. So now let's deep dive and understand this technique. The Lambda function is actually a tiny function without a name, and we also call it anonymous function. So instead of building a whole function, we have like a short way or a shortcut. With one line you can define a whole function, and you will see Lambda is used a lot together with the other data structure functions like the map, filter, sorts, in order to do extra complicated logic on top of your data structure like the list. So how actually Lambda works? So once you say Lambda, then you are like defining a function. It has an input, like for example x, and then you define in the function an expression, and it could be anything, like maybe you are doing some calculations where you say x multiplied with 2, or you are checking specific thing, like for example, is the letter A exist in this input, in this X, and any other expressions. And of course, at the end, you will get the result of this expression. So actually, that's it. You need only two things: the input variable or variables and the expression. So what can happen with the input? And that's it. Okay, so let's try this out. All what you have to do is to use the keyword lambda like this. And after that, you define any variable name for the input. So for example, I need only one variable, so X, and afterward double point in order to define now the expression. So what can happen with the X? We're gonna go and multiply it with 2. It is very simple. Now the question is how to use this. In order to do that, you have to define at the start, for example, a variable, like for example multiply, and then you say equal to the lambda. So that means actually the variable multiply is holding like a formula. We don't know yet exactly what is the value. So now in order to use it, let's go and print, and we're gonna say multiply, and now all what you have to do is to specify a value. So you are treating now the multiply as like any other function, like the print. You define the function name, the multiply, and then you pass for it a value. So here, since we said, okay, we need an X, that means one item, I can go and have a number like 2. So now if you go and execute it, now look at this, we have 4. This is exactly the result of our expression. So 2 multiplied with 2, we have 4. Okay, so now let's take it to the next level where we have actually 2 inputs. So we have 2 variables. So in order to do that, it is very simple. We start with the first input, it's going to be the X, and then comma, and the second input. So now the rest is going to be the same. We're going to have a double point, and now we're going to tell Python what's going to happen with the 2 input. Well, we're going to say X plus Y. So I'm just adding the 2 inputs. So this is our formula. We're going to put the whole thing in a variable name like add, and then after that we have to go and use it. Now we're going to use the variable name, and then we're going to pass this time 2 values, because we have 2 inputs. So we're gonna say 1 for the first value and 2 for the second value. So let's try this out. Now look at this, we are getting 3. So 1 plus 2, 3. Mega easy, right? So now, so far, as you can see, we are using some kind of like calculations on top of our input. But now what we can do, we can make like a check in order to check the input. So we don't want to calculate anything. We are just like analyzing and checking. So our expression will not be manipulating the data. It will be just checking. So now, for example, let's say that I'm going to go and check whether a character or a letter is part of another string. So for example, we can say lambda. We are checking only one value. So it is only one parameter. So the input going to be only one character, so it's going to be only one input. We could use any variable, so you don't have always to be an X. So we're going to say I double point, and then the expression this time going to be a normal check. So we're going to say I in, and then let's have any like string value, for example Python. So I'm checking whether the input is actually character in our string. So that's it. Let's go and give it a name, and then we're going to print the variable name, and now we have to pass any value. Like for example, let's start with like an n. So is n actually a member of this string value? Let's try this out. Well, it is true. So as you can see, we are not changing the value, we are just checking. Let's go and pick another value, like for example z. Is z member of the Python? Well, let's check out. As you can see, we are getting false. So an expression could be anything. Alright, now with this you have the basic understanding on how Lambda works. So for example, if you look at the map function, we said you need 2 things. The first one is how to transform your data, the function, and the second thing gonna be your data, like the list. So now we said we could use some built-in functions and method from Python, like the upper, lower, or is alpha and those stuff. But if you say, you know what, I need to do something specific, so some extra complex logic, we cannot go and use the built-in stuff. We could go and use the help of the Lambda in order to specify what we want to do. So with the Lambda, we're going to define exactly how we're going to transform our data structure, our list. Okay, so now let's practice. I'm going to show you an example that I had in my project. So I had a list of prices, but the issue is that the prices were in string values. And as well, each price has a $sign at the start. So we have 12.50, maybe another price like as well with the $sign, 9.99, and the last last one as well with a $sign 100.0. Now the thing is, with those values you cannot do a lot of aggregations and calculations like the average, min, max. You have to convert it from a string to a float. So that means I have to transform my list from a list of strings to a list of floats. But the challenge is that you cannot go immediately from a string to a float because of those string values. So that means first you have to do some manipulations to remove it and then change the data type to a float. Now I'm going to show you how I usually do it. I don't jump immediately and start writing lambda and stuff. I try to build the transformation like with one value, and if it works then I go to the lambda. So for example, I'm going to say let's have a variable called p, and I'm going to give it the first value 1250. So now I'm going to start like playing with this value. So the first thing that I'm going to go and get rid of the $sign. So how to remove a $sign from a string value? Think about it. Which string methods we have to use? Well, we can go and use the replace. And what we're going to do, we're going to replace the $sign with actually nothing, an empty string. So let's go and try this out. Perfect. Now I don't have the $sign, but still my value is actually a string value. The next step of that transformation, I'm going to go and change the data type. So it's going to be very simple, floats, and then the result of the replace going to be the input for the float, and with that we will be changing the data type. So look at this, we have 12.5, and of course if you want to be very sure we can go and check the type. So as you can see, now we have a float, and this is exactly what I need in order to do some aggregations. So I have actually the formula, and now I have to put it in a lambda. Now the input gonna be only one price. So for example, p double point. Now what we're gonna do with the prices is actually this whole transformation. I'm just go and copy and paste over here. So now I know the input, I know what can happen with my input. Now the next step is to go and apply the whole thing in our list. So in order to do the transformations, we're going to use the map function, and then we're going to pass for it our list. It is the prices. Let me just get rid of this, and of course the output of this going to be an iterator. That's why you have to go and change the data type to a list in order to see the values. And the last thing, of course, I would like to see the output. So let's try this out. Now look at this, I have a list of floats, and this is exactly was my data transformation that I wanted to do. I changed some weird string values to a float. So again, step by step, always think about how to do the transformation, then put it in a lambda, and then use a map function in order to apply the whole thing to your data. It is not that hard, right? Just do it step by step like this, and you can do amazing custom transformations on top of your data structures. Now the same thing for the filtering. We need two things: the rule on how to filter the data and the data itself. Now about the rule, the function, we could use the built-in methods and functions, but if you want some custom specific filters, we're gonna use the help of the lambda again. So that means with the help of the lambda, we're gonna specify exactly how to filter our data in the list. Okay, so let's try this out. We're gonna have a simple example where we have a list of prices. Let's say I have 120, 30, maybe 300, and 80. Now my goal is I just want to see the high prices in my list. So everything equal or higher than 100 should stay in the list. All other prices that is lower than that, I don't want to see it in the list. So that means we have to build a filter, and for that we need some custom logic. Now the first step is to think about how you're gonna write the condition, the logic for the filter, and it's gonna be very simple. The price is gonna be higher or equal to 100. So this is the logic. Now in order to use it for this data structure, we have to go and use the help of the lambda. So we're gonna say lambda, and we're gonna pass for it, of course, one price. Now the question is, what we're gonna do with this price? Well, actually we're gonna check whether it is equal or higher than 100. Okay, so we have the logic. The next step is that we're gonna use the filter function. So we're gonna say filter, and this is the filter logic, and we have to pass for it our data. So what should be filtered? It's gonna be the list of prices. Now, of course, to see the results, we have to change the data type, and I would like to print the results. So let's see what can happen. Look at this. We have a list with only high prices, everything that is higher or equal to 100. So very easy, right? We use the lambda in order to define the custom filter logic. Then we go and use it in the filter function together with our data. So it is easy. This time we're going to go and use a nested list. So we're going to have a list of students with their scores. So let's say in the first list we have the name and as well the score. And let's have another student. Let's say Kumar, and we have 90, And the last one, max. And we have 60. So 3 students with 3 scores. So now let's say that I would like to have a list where the students has a score higher than 70. So anything below that should not be part of my list. Now, of course, this is very specific. You don't have a function for that or a method. You have to build your own custom filter. Let's see how we can do that. So the first thing is that we have to go and select exactly what we are checking, right? So it's going to be the students. And let's go for the row number 0, for example. Now, what we want to check is actually the scores, right? So it is the index number 1. So now this score should be higher than 70, right? Now we can go and test it, of course. So we're going to say print and then execute it. You can see it is true. So the first student is actually matching our rule. Let's go for the second student. It is true. The third student. So with that, actually, we have our filter rule. Now the next step, we're going to go and put it in Lambda. Now let's do that. We're going to say Lambda. Now here it is interesting. What is the input for this function? It's going to be the whole row. So it's going to be a row. So I'm going to send Maria and as well the value. And now what we're going to check in this row is actually the index number 1, right? It is the second value. So we're going to say row and 1. Again, I'm sending to the function the row and I'm checking the second value of the row. If it is higher than 70, then everything is okay. So this is always how we're going to do it. In the nested lists, you send the row to Lambda and then you tell Python what to do with this row. Now, the next step is that we're going to put everything in a filter since we are building a filter. So filter, this is our rule. And then of course, we're going to send it our data. So the students. And now, of course, in order to see the results, we have to convert the object to a list and as well, of course, to print. So now let's try this out. Now look at this at the output. We have Maria with a score 85 and Kumar with a 90, but we don't have max with 60. So actually our filtering is working. So as you can see with that, we have built a custom logic using the Lambda and we used it together with the filter in order to filter our nested list. Now another application for the Lambda, we have the method sort in order to sort your list. So if you use the default, you're going to sort it from the lowest to the highest. Or if you say, you know what, let's sort it from the highest to the lowest using the reverse equal to true. But now how about to define our custom way on how to order our list? And again, we could use the help of the Lambda in order to exactly explain for Python how to sort the list. Okay, so now another challenge maybe to you if you want to pause the video. Now I would like to keep only the students where the first character of their names start with M. So that means by looking to the data, I expect you to have only 2 students in the output, Maria and Max, because both of them starts with M. So pause the video, otherwise I'm going to show you how it works. Now again, I start just with the logic. So let's get any students, like for example, the second one. Now what we are interested is with the first information with the first name. So it's going to be the index 0. And now in order to check the first character of any string, we're going to use the method starts with, and then we're going to tell Python what we are looking for. So we are checking whether the value starts with M, and actually that's it. So let's go and print it out and execute. So as you can see for Max, it is working. Let's go for Kumar and try this out. We are getting false. So actually my logic is ready and I'm going to put it in Lambda. So Lambda, as usual, we're going to pass the whole row, double points, and then we have to specify which value in the row. Well, it's going to be the first value, the first name. So the index number 0. And then we're going to say starts with M. So I have the whole logic. The next step, I'm going to go and put it in a filter in order to filter my data. Students, and same thing, list, and the last one, print. Now I'm just going to go and comment this out. So let's try this. Look at this. We have now the students where their first name begins with M. So as you can see, it is not that hard, right? Do it step by step. The first one is to define the filter logic using Lambda. And after that, go use the function filter together with your data in order to filter your list. And that's it. All right, my friends. So that's all about the Lambda. It is an amazing technique in order to create your custom logic in very short and easy way. And it's going to be great assistance to use it together with other functions and methods like the map, filter, and the method sort. So this opens the door for many flexibility in order to define your logic. If you like this type of content, then support the channel by subscribing, liking, and commenting. This really gonna help the algorithm to reach nice people like you. If you're still here, then thank you so much for watching, and I will see you in the next video. Bye bye.